Everyone. Welcome back. I hope you're having a good day. We're going to be, as the essential question states, kind of building off of what Mrs. Vogel talked about yesterday and kind of talking about some different forms for quadratic equations. So that'd be like parabolas. So these are kind of the two forms that we're going to be looking at today. A lot of what we're going to do today is kind of build some relationships between what we would know as standard form versus what we're going to call vertex form. And so a lot of this is going to have an application for some different types of equations coming up. So just be kind of mindful of that if you're already content with, let's say you know this form really well, that's great, but we're going to be using the skills and stuff that we're going to build today quite a bit in the next coming days. So just kind of stay open-minded as we work through some of this stuff. So first we're going to start with the section title. It doesn't really have a specific section in your textbook, so I'm going to say, I'm going to just call it vertex form for quadratics. And I believe the date for today should be, let's see, April 15th, I believe. And if it's not, then obviously feel free to fix it. I'll just try to do a little fix. All right, so the question for today is how can I relate standard form, which is typically going to be in the form of ax squared plus bx plus c, to vertex form, which is this form. Now, unfortunately, sometimes in your textbook, they like to call this standard form, but we're going to refer to it as vertex form. So I would reference back to this is standard form, and this is what we're going to consider vertex form. So this is probably the one that you're most familiar with and comfortable with. This is kind of where we're going to head and move towards. So what I would like you to do first is, just as a warm-up, just as some review, I'd like you to press pause when I'm done, and I'd like you to identify all of the different transformations that you could identify for this equation. So press pause, write those out, and then we'll talk about why we're discussing that now. All right, so hopefully you had that there is a reflection over the x-axis, and that's because of the negative in front. The 1/4 implies that there is a vertical shrink, meaning that my parabola is going to be kind of like wider in a sense. The subtraction of 3 means that we're heading to the right 3 spaces. And then the subtraction of 2 means that we're shifting down. So naming transformations is kind of a good way to visualize how a function is potentially changed when I compare it to the parent function. So this right here would be considered vertex form. And so we're going to talk about how to take something that's in standard form and kind of understand its relationship between standard form and vertex form. So if, let's say, I'm just going to kind of write a random equation. Let's say I had the equation y equals 2. Let's do x minus 1 quantity squared plus 3. Okay, this is considered vertex form. And if I think about it, it's pretty simple if I want to go from vertex form to standard form. So each form has its benefits, and that's kind of what we're going to talk about in a little bit. So what I'm going to do first is transition this into standard form. So my first question is, how could I do that? So if I simplify this, so I'm going to write that out twice. Remember, squaring a quantity means writing it out being multiplied by itself. And if I simplify this, that's going to then transition this into what we would consider standard form. So first I'm going to do this multiplication. So that should give you the trinomial x squared minus 2x plus 1. And then if I continue to simplify by distributing, and then combine like terms, this would be considered the standard form. So basically, if I think, so standard form would look like this. 4x plus 5. And then originally the vertex form was y equals 2 times the quantity x minus 1 squared plus 3. These are my two comparisons. So those are the two different types. What I want you to start thinking about is, and there's not necessarily a correct answer, but I want you to start thinking about which form would be easier to use to graph. Honestly, I think you could make an argument for both of them. So for example, in vertex form, I should be able to identify, if it's called that, I should be able to identify the vertex, and we'll talk about that later. I should very easily be able to talk about the axis of symmetry, and I know these are kind of some throwback words, so we'll do more of a review of like the graphing side of things in the coming days. Over here, I can still find, so if I'm talking about standard form, I can still find the vertex. I can still find the axis of symmetry. And for these, I'd have to use some formulas, so like throwback. If I wanted to find the vertex, I'd use the formula, or the axis of symmetry, I'd use the formula x equals opposite of b over 2a, and then that would tell me where the vertex is, or where the axis of symmetry is, and then I could use that to find the vertex. I can very easily find the y-intercept, and that's just going to be this last number here. So I think you could really make an argument for either one of these would be fairly easy to use to graph. Likewise, I think based on the fact that a lot of it is just algebra, either form would be acceptable. However, I want you to kind of start thinking about what were some of the algebra ways that we actually found x-intercepts. So instead of graphing, what are some algebraic ways that we found x-intercepts? So hopefully coming to mind would be like, I'm sure some of you are thinking the quad formula, which is a pretty easy one to use. Sometimes factoring, if that's appropriate. And then everybody's favorite, or the one that we're going to be using, is completing the square. So if, let's say, I were trying to solve having something in standard form, I could probably use the quadratic formula. I could definitely do all of these methods. If I had something that looked like this, where it's in vertex form, that kind of leads me to probably relying on completing the square. Yesterday, you would have gotten some information about how to complete the square. So if you need some review, I'd maybe go back and look at that. So for the graph, if you want to go through and actually like lay out the steps, the vertex would end up being at 1, 3. The axis of symmetry would then be at x is equal to 1, so there'd be that line of symmetry. And then we already have the y-intercept from this form. So 1, 2, 3, 4, 5. And then I can use that as a reflection point. And then from there, I can either use the table feature in my calculator or plug in my own values for x and find appropriate outputs. So I think another point would be 3, and then I think it would be all the way up top. So I think it might be 310. Hopefully I'm right. And then I can reflect that over, but I'm just kind of like sketching it out. So what our goal is not necessarily to do all the graphing and all the solving, but to see, instead of me going from vertex form to standard form, going in the opposite direction, because there's will be value to writing quadratics and other types of equations in kind of like a standard graphing or vertex form, in this case, form. So with that being said, I want you to put your completing the square hat on.